Hey everybody, welcome to Math with ACE. We are focusing on statistics today. We're going to be dealing with hypothesis testing for two groups rather than a single group. So we're dealing with either two proportions or two means. And in hypothesis testing, we will typically set up our four-step process where we make a statement of what we're doing, where we have our null and alternative hypotheses with our parameters defined. We check our conditions, then we calculate a test statistic and the probability of obtaining that test statistic, or one more extreme, randomly by chance if the null was true. And then we're going to draw a conclusion about whether we have evidence for the claim and should reject the null or not. So a few things to think about. Whenever you're talking about hypothesis testing for two proportions or two means, we're talking about a difference, which we note with a subtraction sign. Our null hypothesis is always going to be a statement of equality where their difference either equals 0, which is most likely the true, or it's equal to some value. So P1 minus P2 equals 0 or some hypothesized value, or mu1 minus mu2 is equal to some hypothesized value, which is typically 0. And then the alternative is that their difference is either greater than that, less than that, or different from that. Some other conventions might use not equal to, less than, or equal to. We're not doing that. We are assuming equality in the null hypothesis and going from there. Now, you could, using techniques of solving equations, you can do the inverse of the subtraction to move one of the variables over to the right-hand side. This is the same thing as saying P1 equals P2, or P1 is greater than P2, or P1 is less than P2, or P1 is different from P2. So that notation is also appropriate. It's whatever you feel more comfortable with. The one thing I will say is if your hypothesized value is not 0, then this is not going to work. This is only when you have 0, otherwise you've got some value dangling in there. So then you need to define what your parameter is. Where P1 is the true population proportion of people in Napa County who are in favor of this new bond measure. Or mu1 is the true population mean age of people who are going to vote in the next election, something like that. And then you also have to do it for the second proportion and the second mean when you're dealing with your problems. You're given a level of significance, and then when we move on to checking our conditions, you have to check your conditions for both. Random is the same, independent is the same. You are doing the same thing just twice. So check your conditions for both groups. Both sample A and sample B need to be randomly selected. Both sample sizes need to be less than 10% of their respective groups. The one difference for large counts or normal comes in the proportions. But we need to compare. When we were doing hypothesis testing for one sample, we use the initial value. We do not have an initial value in this situation. So for one z-test for proportions, we were checking in P naught is greater than 10 or N1 minus P naught is greater than or equal to 10 using the hypothesized value. We do not have a hypothesized value. And so for these conditions, we need to be using the sample proportions again. So this looks like sample size 1 times the sample proportion, sample size 1 times the complement of that. This is successes and failures. Sample size 2 and its proportion, and sample size 2 and the complement is going to give you your successes and failures. Checking conditions for normal, for means, either the populations are normal, the sample sizes are large enough, or you're graphing. That does not change. Your test statistic is a z-score or a t-score, but now we have multiple things that we're including with our two samples. So our sampling distribution is a little bit different because remember, you cannot subtract away variability, and so it's important that you have the right formula. We're doing z here. I will remind you that for one sample, we had z equals p hat minus p naught over p naught 1 minus p naught over n. But we are assuming that the null hypothesis is true, so we're doing a pooled proportion. And that pooled proportion is where you take your successes and your successes of each group added together divided by the sample size added together. So your combined proportion is successes from one plus successes for the other over sample size 1 plus sample size 2. And then we can adjust our z-score to be the point estimate or the difference in the sample proportions minus the difference in the population proportions, which is most often 0. And then that is divided by the pooled proportion, 1 minus the pooled proportion, times 1 over the sample sizes. It's very similar to P naught, 1 minus P naught, because it's essentially pooled proportion times 1 minus the pooled proportion over N1 if you distribute, plus pooled proportion times 1 minus pooled proportion over N2. This is just keeping it collected. It's the same thing as doing pooled proportion 1 minus over N1 plus pooled proportion 1 minus over N2. So it's very similar to when we did the confidence interval, except in this case, we are just assuming that the null is true and that those proportions are equal, so we're combining that group. For a mean, our t-score is going to be very similar. Remember, in your one sample, we had t equals x bar minus the hypothesized value initially over the standard deviation of the sample divided by the sample size. We're going to expand that to be the difference in the sample means minus the difference in the hypothesized means, which more often than not is 0, and then divide that by standard deviation of the sample in the first group squared over the sample size plus the standard deviation of the sample group, second group squared over N2. So you're just extending these formulas a little bit. And more often than not in my class, what you'll do is likely fill in the numbers to show that you know what each of the pieces are, and then we'll use technology to perform the calculations, just to kind of, we really care about the analysis of what's happening. So in the end, we draw our conclusion in the same way we would in any situation for hypothesis testing. You look at your p-value. That's the probability of obtaining the data that you did from the sample, or data more extreme, assuming that the null is true, randomly by chance. And if that probability is small, then it means it's likely that the null really isn't what we are looking at, and we have evidence for our claim. So if our p-value is low in comparison to our threshold that we decide, we reject the null. And if it's not, then we fail to reject the null, and we either have evidence or we don't. So if you go back to initial hypothesis testing videos, I talk more in depth about what it means to make conclusions and those things, but this follows the same way. So the main difference in hypothesis testing is your test statistic is a little bit different, and we are not multiplying by a hypothesized value for our proportion, because typically we don't have values for the proportion, and we're assuming that they're equal. And then in our null and our alternative, there's a couple different ways you can write that. Thanks for watching.